Welcome. Today, we're going to dig into a topic that's, well, literally right under our feet, but it has a huge impact on our entire country and our economy. We're talking about how Canada manages its non-renewable resources, the stuff we can only use once.
So just look at these two images. On the left, you've got an oil sands operation in Alberta. It's absolutely crucial for our economy, but you can see why it gets people talking. Then on the right, a wind farm in Ontario. It looks like the clean energy future, right? But believe it or not, even these projects can stir up controversy. It just goes to show when it comes to resources, there's always a debate. And that really gets us to the heart of the matter, the big question we're tackling today. How in the world do we balance the incredible economic benefits of these resources with all the environmental and social costs? It's a really tough one, and that's what we're going to unpack. Okay, so here's our game plan. We'll kick things off with that core controversy. Then I'm going to show you a really important tool called the RP ratio. It helps us figure out what's left. After that, we'll dive into our fossil fuels, dig into the world of mining, uncover the amazing story of Canada's diamond rush, and then bring it all back to that final, tricky balancing act.
So why is managing these non-renewable resources so incredibly difficult? I mean, it's even tougher than managing renewable things like forests. Well, the answer is pretty simple and kind of scary. When they're gone, they are gone for good. There are no do-overs, which makes the stakes just incredibly high. And this leads to a very human, very common reaction called the NIMBY phenomenon. It stands for not in my backyard. You know how it is. We all want the benefits, right? The gas for our cars, the electricity for our homes. But the second a new mine or pipeline is proposed nearby, well, that's when local opposition can get really intense over concerns about health, the environment, and property values.
Okay, so if we're going to manage these things properly, we have to start with a really basic question. How much do we actually have left? And to answer that, we use a simple but really powerful tool called the R/P ratio.
The first piece of the puzzle is reserves. Now, this isn't the total amount of a resource on planet Earth. It's just how much we think is in the ground, based on the exploration we've done so far. And you got to remember, it's just an estimate that's always changing. The second piece is production. This one's easy. It's simply how fast we're using the stuff, how much we're pulling out of the ground every single year. You can think of it as our annual consumption rate. Now, let's put it all together. You take the reserves, you divide that by the annual production, and what you get is the R/P ratio. And what does that number tell you? It tells you how many years of that resource we have left if we keep using it at the exact same rate. It's a super useful snapshot of how sustainable our use is. Let's see how this works in the real world. Check out bauxite and iron ore on this chart. Looks like we have a pretty healthy supply, right? More than 100 years worth. But now look over at tin. Whoa, its RP ratio is way, way lower. That means we have far fewer years of tin left compared to the others. And that's exactly why this ratio is so critical. All right, let's switch gears and talk about our first major category of non-renewables, fossil fuels. Yep, we're talking oil and natural gas. And the fossil part is no joke. These fuels were literally formed from the remains of plants and animals that lived over 100 million years ago. Pretty wild. Now, a modern method for getting at these fuels that you've probably heard a lot about is called fracking, or hydraulic fracturing. It's basically a whole set of technologies designed to unlock huge amounts of natural gas and oil that used to be impossible to get to because they're trapped deep, deep underground in shale rock. So how does this actually work? Well, they drill a well thousands of meters down and then turn it horizontally. Then they blast a high-pressure mix of water, chemicals, and sand down there to crack the shale. But here's the key part, the thing that makes it all work. What keeps those cracks open so the gas can escape? It's the sand. The sand gets lodged in all those little fissures, propping them open so the gas can flow out. As you can imagine, fracking is a huge debate. On the one hand, supporters point out that burning natural gas produces a lot less carbon dioxide than burning coal, so it's actually helped reduce greenhouse gas emissions. But on the other side, you've got some major environmental concerns, like the risk of contaminating groundwater supplies and the impact it can have on farmland. Okay, so let's move on to our second major category, minerals. We're talking about the building blocks of our modern world, everything from the iron in our skyscrapers to the gold in our smartphones. And here's a key difference from fossil fuels. Many minerals, like the aluminum in a soda can, can be recycled again and again. Here's a fun fact. Finding valuable minerals isn't actually the hard part.
The real challenge is finding them in a high enough concentration to be called ore. See, ore is any rock that has enough of a mineral in it to make mining it actually profitable. If it costs more to get it out of the ground than it's worth, well, then it's just a rock. So, how do we get this stuff out? Well, there are three main ways. For resources in flat layers near the surface, like coal or oil sands, we use strip mining. For deposits that are near the surface but go way down deep, we use open pit mining. And for those really valuable ores that are located far, far underground, we have to use underground mining.
Take a look at this. This is the Ring of Fire in northern Ontario. It's a massive deposit of chromium, which is a super important metal for making steel. It has enormous economic potential for the province. But, and this is a big but, look at the map. It's located right in the middle of the traditional territories of 9 First Nations. This makes its development a really complex issue of rights, money, and environmental protection.
Now, for one of the coolest Canadian resource stories from the last few decades. You know, for a long time, geologists had a hunch that Canada had diamonds. But it wasn't until 1991 that they were finally found. And that kicked off an absolutely incredible diamond rush. And this map just shows you how crazy remote these mines are. We're talking way up in the Northwest Territories. This is not like building a mine on the edge of a city. This extreme remoteness makes everything way more difficult and expensive. They even have to build temporary ice roads every single winter just to get heavy supplies in. Now, these numbers tell such a fascinating story. If you were to just rank countries by the weight of diamonds they produce, Canada wouldn't even be near the top. But look at the value of that production. We're number 3 in the world. So what does that tell you? It tells us that Canadian mines are producing incredibly high-quality gemstones, not just the cheaper industrial diamonds.
And the speed of this industry's growth was just staggering. I mean, look at this chart. In 1996, Canada's diamond production was pretty much zero. Just a decade later, look at that jump. At its peak, Canada was producing between 15 and 20% of the entire world's diamonds by value. That's a truly amazing rise to the top.
And all of this brings us right back to where we started. It doesn't matter if we're talking about oil sands or fracking or diamond mines, we always come back to this one central challenge. How do we find the right balance between the economic benefits a project can bring and all of its environmental and social impacts?
So I'm going to leave you with this final thought. Almost all of the new resource discoveries in Canada are happening on lands that are either owned by or are subject to land claims from First Nations, Métis, or Inuit peoples. So maybe the most critical question for our future isn't just what we develop, but how we do it. How can we possibly move forward in a way that truly respects Indigenous rights while also developing the resources that fuel our modern world? That right there is the ultimate balancing act.